Alright, so continuing on here with the second box, the absolute value equations. And now we've got some more generic, when there's stuff that's inside this absolute value that isn't just x. So what if there's something times x or something being added to it afterwards? And so got a couple of examples over here that I want to go through that I think will help us to understand. Um, we have we already went through the absolute value of 3, and we found out, hey, that can either be a positive number or a negative number. If it's positive, then x is equal to positive 3, and if it's a negative value, then x is equal to negative 3. When x is equal to an inequality, again, there's a positive and a negative situation. That it could either be a positive value for x or a negative value. And if it's the positive, everything stays the same. X is less than 2. However, if the value here is negative, then we have x is greater than negative 2. We multiply this both really by a negative. However, that negative value in there becomes that positive, and 2 becomes a negative 2, and we got to make sure we switch our inequality. Same thing there with greater than. Now, what if we have some other stuff going on inside the absolute value? So what we're going to do is, once we get the absolute value all by itself, you could have times 2 outside or plus something afterwards. But once we can get the absolute value all by itself, then we're going to split it up just like we did with these ones right up above. So whatever x plus 2 is, I don't know exactly what it is, but it either can be a positive value or it can be negative. If it's positive, then x minus 2, whatever that is going to be equal to 7. I'll solve that inequality. However, if whatever the value of x minus 2 is negative, then x minus 2 is going to be equal to the opposite of the 7, that equal to negative 7. And I've got two inequalities that I'm going to go through and solve. I'm going to add 2 to both sides, and so x is either equal to negative 5 or x is equal to 9. And you could graph those 2 points on a number line, 0, negative 5, and over here positive 9. All right. Same deal here with the inequalities. It either can be a positive value or a negative value. If it's negative, then negative 2x plus 3 is going to be greater than, that inequality's got to switch, greater than negative 10. And if it's positive, I'm going to go ahead and write it down here below, then negative 2x plus 3 will be less than 10. For both of them, subtract 3 for both sides. We have negative 2x is greater than, what is that, negative 13. And so x will be, after we divide both sides by negative 2, x will be less than 13 halves. Over here, subtract 3, and we get negative 2x is less than 7. Divide by our negative 2, and we get x is greater than 7 halves. All right, so we went ahead and solved those inequalities there. Last situation probably looks a lot like the first. However, be careful with absolute value problems. I'm going to go ahead and, if you already see what's going to go wrong here, then excellent. But let's pretend for a second that we don't. We're just going to jump right in and go, oh, well, this can either be a positive or a negative. If it's negative, then x plus 2 is equal to 4. And if it's a negative value, then x plus 2 equals negative 4. Run on through. Hey, x is either equal to 2 or x is equal to negative 6. And we'll think, all right, we got the answers. There's just one problem, and they're both false. If we're to plug them back in, 2 plus 2, well, that's 4. Take the absolute value of 4, and that's still 4. But 4 is not equal to negative 4. Same thing with negative 6. If we plug in negative 6 here, and negative 6 plus 2, that's negative 4. Okay, maybe we're going to get there. Oh, but then we take the absolute value, and again, it's 4 equals negative 4, which is false. These are both false answers here, and we need to be really careful about that. Maybe now's a good time to go look back at the problem itself. It's saying that an absolute value of some number is going to be equal to a negative number, and just realize that that can't actually happen. We didn't do anything wrong with the process. We just need to realize what it was we were actually trying to do. We're trying to set some number that always has to be positive equal to some number that's going to be negative, and that just can't happen. So here we'd have no solution.